Assalamu alaikum. My name is Mubin Malik, and in this lab number 10, we have to implement encoder, decoder, a multiplexer and a demultiplexer by the use of universal gates. The universal gates including AND, OR, NOR, NAND, etc. So the first circuit that I'm going to implement is the circuit of an encoder. So what an encoder does is it takes an input at a respective terminal and gives out the binary of that input at the output. So this is the bit number, this is the least significant bit, bit number 0, and this is the bit number 1, which is the most significant bit of the output. And these are the four inputs. This is the least significant bit, while this is the most significant bit. So this is the enable, which basically acts as a switch for the circuit. It gives the circuit only gives the output when this enable is turned on. So if I run the circuit for you, this enable, you can see, is turned on, but there is nothing at the output because none of the input is on yet. So when I turn this on, this is basically something to understand, that whenever this input is on, this means that there should be a binary 0 at the output, which in this case is available. Now when this is off and this is on, we can see that this is the input number 1. I have written input number 2, but if you start from 0, 1, 2 and 3, this input is the input number 1. So input number 1 gives a binary of 1, 0, 1 is equal to 1. This input gives a 2, 1, 0 is 2 in binary, and this gives a 3, 1, 1 is a 3 in binary. So this was the circuit of the encoder, and let's get on to the circuit of the decoder. Now what the decoder does is that it takes a specific input in the form of two select lines, and the combination of the select lines determine which of these outputs has to be on or at a higher logic. So if I run the circuit for you, this enable works as the switch for the circuit. So when the enable is turned on, so the first combination possible is if both of these select lines are 0. So the 0 means the least significant bit, or the first input is on. So if I turn this on, so 0, 1 is equal to 1. So the first LED is on, 0 and the first. Now if I turn this on, 1, 0 means 2. So the second or the 0, 1, 2 LED is on. And if I turn this on, so this fourth LED is on, which actually is 0, 1, 2, 3, and 1, 1 is equal to 3. So this was the circuit of the decoder. Now the next circuit is of the multiplexer. What a multiplexer does is, as I have explained in my previous videos, that on the basis of the combination of these select lines, it is determined in the circuit that which of these outputs has to be shown at which of these inputs has to be shown at the output. So the combination of the select line will determine which of these data lines has to be at the output. So if I turn this circuit on, the combination right now is 0, 0. So if I turn data 1 on, it is shown at the output. You can see that none of the other data lines are giving the output. So this means that this combination connects this data 1 to the output. If I turn the second combination on, which is 0, 1, the data line 2 gives the output, while no other data lines give the output. This second combination means that the second data line is connected to the output. Now if I go to the third combination, which is 1, 0, you can see that the third data line is connected to the output and no other data lines are giving an output. Now for the fourth combination, which is if both select lines are 1, you can see that the data line 4 is giving the output. Now the next circuit we are going to test is of the demultiplexer, which is the opposite of this circuit. This circuit right in front of you is of the demultiplexer, and what the demultiplexer does is it basically is the opposite of the multiplexer. So this is only the single data line that has to be shown on the output. Now you can see that there are 4 outputs, and at which output this data has to be shown is determined by the combination provided by these 2 select lines. So the first combination is 0 0, and if I turn the data on, you can see that the first LED is on, which means that the first line is giving the output. If I turn the second combination on, which will turn on the second LED, and the data is connected to the second output. Now for the third combination, the data is connected to the third output, and for the final fourth combination, in which both these select lines are 1, the data is connected to the second output, fourth output, sorry. So this was the implementation on Proteus. The next thing we have to do is implement these circuits on the Verilog, and I have written the codes which I will show you. Now this part right here is the coding part, in which this is the code for the decoder, this is the enable line, and these 2 are the selection lines, and these 4 are the outputs. This circuit is built on the same logic as the Proteus ones, so the wires are declared as NOT selection 1 and NOT selection 2, and these NOT selection ones are combined at this NOT gate, and these AND gates represent the final circuit of the AND gates, which I will show you in the RTL view, and these are the inputs, and this comes as the output Q, R, S, and T. So if I go right here, this is the RTL view of the decoder, and this is the output. So if I explain the output for you, the circuit will only work when the enable is 1, not when the enable is 0. So you can see there is nothing at the output Q, R, S, and T. So when the enable is 1 in this section right here, you can see that it depends now on the selection lines S1 and S2. So when S1 and S2 are 0, the first output gives a high. When selection line 1 is 0 and the selection line 2 is 1, the second output gives a high, and so on till the third one, and it all goes in a sequence, and it depends on the combination of S1 and S2. The next circuit is of the DemuX. Now the DemuX is also built the same way, which essentially is a decoder, but instead of an enable, it has a data line which is shown at the output. Now the code is the same, and this is the RTL view. It is just made in a little bit different way. I have used the assign operator for this circuit. Now this right here is the RTL view, and this is the output. The output, as also you can see, is the same as the output for the decoder. This is the same output as the output for the decoder. The next output is or the code is of the encoder, and the encoder is also built using the same gate input method. These are the 2 OR gates that will then join the AND gate, and I have used the bit input system this time. Now the input consists of 4 bits and the output consists of 2 bits, which is essentially what an encoder does. Now this is the RTL view, and this is the waveform. Now if I explain the waveform for you, this was a kind of priority encoder, but it wasn't. This was, now if I explain the output to you, the circuit again will only work when the enable is 1. So we have to see the output at this section right here when the enable is 1. So now our 3 inputs are 0 0 0 1, 0 0 1 0, 0 1 0 0, and then this 1 0 0, 1 0 0. So for the first 0 0 0 1, the output right here is 0 0 0 0. For the second input 0 0 1 0, the output is 0 1, which is the which is basically 1, as the first bit is on. The next output is 0100, in which the second bit is on and it gives the output as 2, and the last is the 1000 where the third bit is on and it gives out the output as 3. So this was the encoder, and this is the code of the MuX. I have made a MuX for you in the Verilog before, and this is the gate implementation of the same MuX. And these are the inputs, these are the wires, and these are the knot connecting the controls to their knots, and these are the AND gates that will give out the output, and this is the OR gate which connects all those four outputs from the AND and connect them into one. So this is the RTL view, and this is the waveform. So if I explain the waveform to you, this again will work on the combination of the control lines. So for the first combination, when control 1 is 0 and the control 2 is 0 right here, you can see that the output follows the first input from here to here. Now the next combination is when control is 1 and the control 1 is 0 and the control 2 is 1. Now the next output being followed is the the next input being followed is the second input IN2. You can see right here from this section to this section, you can see that the input 2 is being followed. For the next section, input 3 is being followed. You can see from here to here, this is the input 3, and for the last section, input 4 is being followed from here to here. This is the input 4 and this is being followed at the output. So the cycle starts again from here. So this was the circuit of MuX, and the implementation, the gate level implementation of all the encoder, decoder, MuX and DemuX is shown you in Proteus and Verilog. Thank you very much. Allah Hafiz.